Hi there, Mr. Boer here for week 5, physics online or remote learning. We're going to focus on gravity, universal gravitation, and satellite motion in this week's lesson. Kind of goes along if you still have kept your book. It would be 12, 13, and 14 in your book. The new version of it, it's got all the same stuff. They just combined 12 and 13 together. So if you look here, it says 13. It'll be 13 and 14 on the online companion. Um, but basically, when you talk about gravity, it was a concept that Newton was able to actually come up with. I know he followed off of some of the earlier ideas of Galileo, similar to what we talked about when we were going over um, motion in general, how he went over Galileo's law of inertia, basically Galileo's idea of inertia, and Newton turns it into a law. So he does the same thing. He takes this idea that Galileo came up with, and he kind of puts it into um, a new idea, and how that it's not just a thing in motion. He was looking up at apples falling, the moon falling, and all these ideas, and how they kind of matched with what Galileo had said. So I'm not going to get too much into the history behind it. You can look at the full PowerPoint and you be able to go to the videos that I have and get all of the history part of it. But the idea, whether he actually saw an apple falling or not, he comes up with his idea of gravity during the plague, where he was being quarantined, which is kind of familiar, being quarantined from something. And he went back to his family farm from Cambridge, where he was a teacher there, and he's sitting outside of an apple orchard and notices the apple fall in the same line as the moon, and kind of said, "Well, the moon must be falling just like the apple is." Whether any of that's quite true or holds true, it kind of is some interesting history there. Um, but in all essence, he comes up with the fact that the moon is falling just like the apple was falling. But what it's doing is falling around the Earth. Um, so when you come up with this hypothesis, if you were to take a cannonball and shoot it, it creates that curved path or projectile path that we had made. But it'll eventually hit the Earth. And if you shoot it a little faster, it goes a little farther. Still hits the Earth if we're looking at D. And then if he shoots it a little faster, it's going to fall over here where F's at. If he shoots it even faster, straight horizontal, it's going to end up where G's at. And so, but eventually, if you shoot it fast enough, what does that projectile do? It orbits the Earth. So the projectile motion that we talked about back in chapter 3 is very similar to the satellite motion that we're going to talk about in this chapter. It goes through, like I said, a history of how far it has to fall. Newton, and we give Newton the kind of title of being a genius for a reason, because he was able to think outside of the box and come up with things that no one had ever even thought of. But the fact that the moon falls 1.4 millimeters, we do find out later that gravity isn't as strong there as it is on the Earth, because it's farther away from the center of gravity. But it becomes clear, and he puts an end to all of the idea that the Earth is the center. So he goes along with the Copernican view of the solar system, saying that the Earth just follows around the sun, just like the moon follows around the Earth. So it kind of puts everything into play, and everything. The way that the moon falls around the Earth is similar to the way the Earth falls around the sun and the solar system, and the way our solar system falls around and moves around the galaxy. Kind of put a final cap to all of those things. If we want to look at what his universal law of gravitation is, it's basically a mathematical equation. It's the only math you're going to have to do in this section. But we can figure out the force. In this case, the force of gravity is proportional to the mass of the two objects. So any two objects, the pencil on your desk, the paper on your desk, any two objects, you and your phone, if you're holding on to, any two objects are attracted to each other by this force of gravity. But the problem is the fact, if you have really small masses and the distance between them, you end up, the gravitational force is too small for it to actually be noticed. So you need